All right. Oops, sorry. Put your phone away. Okay. So here we go. We're going to take a look at, on page 577, we're going to look at problem number 49. Find the dimensions of a rectangle. You should be able to do these problems. Find the dimensions of a rectangle with a perimeter of 200 and an area of 500. Now, you can do this in more than one way, which is always the case, right? You can always do these in more than one way. Today, because we are practicing systems of equations, let's set up two equations. Let's set up an equation for perimeter and an equation for area. Again, you wouldn't have to do the problem that way, but because it kind of is what this lesson is about, let's go ahead and do it that way. So, what would a perimeter equation look like for this rectangle? Well, you're going to have to assign variables, right? You could use L's and W's for length and width, or X's and Y's, or whatever letters you want. But if we're doing perimeter, Maggie says 2x plus 2y equals 200. Are you okay with that? For purposes of solving, I'm going to go ahead and simplify that and say x plus y equals 100. Is that okay with everybody? Now, what would my area equation look like? xy equals 500. So there's my second equation. Now, is everybody still with me? Now we're going to solve this. We're going to solve it using substitution or elimination and looking at the setup, probably substitution this time. So what do you want to substitute? So up here you want to say x equals 100 minus y. Now, are there other things you could do besides that? Yes. But is that okay? Yes, we'll just go with that. So then I'll take that and put it in right here. So 100 minus y times y equals 500. What kind of an equation is going to come out of this? A quadratic. And you know what to do with a quadratic equation. We get it set equal to 0. And then solve it. And what are your choices? You can try to factor it. No guarantee it'll factor, but maybe it does. Or you could use the quadratic formula, or you could complete the square. So you just get to pick what's easiest for you. If I have a calculator, I like just to do the quadratic formula, unless the factoring pops out at me. Does anybody see any factoring right off the bat? I don't. So I'm going to go ahead and use my quadratic formula, which would say what? Y equals
100. Square root.
The positive 100 plus or minus the square root of 100 squared minus 4 times A times C all over 2A. So 100 plus the square root of 94.7 for one of my answers. I would appreciate a double check on that. And I got 5.28. This was 72. 5.28 on the other one. Now, obviously, if we would come up with a negative answer, which we didn't, but if we ever would come up with a negative answer, we'd have to throw it out, because the side of your garden can't be negative, right? Okay? Now, let's answer the question then. We got two values for y. So the width of this garden, or length, whichever one this is, could be 94.72. In which case, what would this dimension be? It would be 100 minus that, which ironically is 5.28. Right? So the dimensions of the garden are 5.28 by 94.72. All right, let's look at number 51. You remember these probably from Algebra 1, where you're going upstream and downstream. We're in our book right now. Okay. We're on page 577. We're going to look at that sheet in a minute. But first I want to set up a couple word problems for you. Okay? All right, anybody have any thoughts about number 51 on page 577? How about variables? In the last problem we had two variables, width and length. What do you think our variables are going to be in number 51? Okay, read the last sentence. What are we finding?
Rowing speed and speed.
Okay, so we're going to let R be the rowing speed, and we'll let C be the current speed. You okay with that? Okay, how many of you have ever rowed a boat or ridden a bicycle or even walked? Have we all done that? Okay. Does the wind, when you're out walking or riding your bike, does the wind impact you? Let's say the wind is blowing hard. Does it impact you?
Yes.
Yes. If you're out rowing your boat in a river or a stream, does the current impact you? When you're paddling your canoe, does the current impact you? Yes. It matters whether you are going with the wind or the current, if you're in water, or against the current. It matters. It makes a difference. What happens when you're going with the wind or with the current? What happens to your speed? You go faster, right? If you're going against, it slows you down, all right? You have a fundamental formula in mathematics that says distance equals rate times time, right? Let's look at the problem. Hank can row a boat 1 mile upstream in 24 minutes. Now stop right there. What's the distance?
1 mile.
1 mile. So 1 equals, distance equals. What's the time? 24 minutes. Now normally speeds are measured in miles per hour. So I'm not going to say 24 minutes. I'm going to say 24/60ths, whatever that is. That's my time. Now it's in hours. What's my rate? Now, it says he is going against the current. So if he's paddling at this speed, but the current is pushing back at him at this speed, what will be his actual speed? R minus C. Because when you are, here I am paddling my canoe, but the current's pushing me back. So if I'm paddling at 10 miles an hour, but the current is pushing me back at 4 miles an hour, I'm only going to go 6 miles an hour, right? He can row the same distance, 1 mile, downstream in 13 minutes. So what's his time? 13/60. Oh my, now there's an add up here. What's his speed? R plus C. If the wind is pushing you, doesn't it add to your speed? Okay, what do you want to do with this mess? I would probably get rid of that fraction. So that top equation would be 60 equals 24R minus 24C. I hope I didn't do too much in one step. I multiplied by 60 to clear the fraction, and then I went ahead and distributed. So then my bottom equation would be 60 equals 13R plus 13C. What do you want to do here? I hear some elimination talk out there. So since we have a calculator, we don't care what numbers we use. But if we multiply this one by 13 and this one by 24, would these cancel out?
Yeah.
So that's, I guess, what I'll do. Even though you have lots of different ways you can solve this problem, and we're actually even going to learn some more in this chapter. Elimination works great. Arithmetic okay? So we got rid of the C's just like we thought we could. I got about 3.6 miles an hour. If I did all that right. Now that's how fast we're rowing. How would we then find how fast the current is? We would take that number and you could plug it in here, you could plug it in here, it doesn't matter, plug it in somewhere and find out the current speed, the speed of the current. All right, we're going to set up one more. We're not going to solve it. We're just going to set it up, and then we're going to start doing some matrix stuff. Take a look at number 54. I think we may have talked about these earlier this year. Mixture problems. Anybody remember our general setup for the mixture problems? Anybody remember amount times percent plus amount times percent equal amount times percent? Now in this case it's a little bit different because they didn't give me percentages. What did they give me instead? Money. Money. But the money is going to act just like a percentage. So we're going to take the amount, okay, what am I mixing together? Peanuts and cashews. So the amount of peanuts at $1.70 per pound plus the amount of cashews at 455 pounds is going to add up to what? What am I going to end up with? 5 pounds of 280. Now you can do this 2 different ways. Well, probably more than that. What do you want to put here for the amount of peanuts and the amount of cashews? You want to just use X and Y? That'll work. I mean, you can put X and Y. That's perfect. However, if you put X and Y, so X is the number of pounds of peanuts and Y is the number of pounds of cashews, if you do that, you need another equation. You can't solve this if it has 2 variables in it. If you have 2 variables, you need 2 equations, just like we did with the boat problem. Okay? What would be another equation you could come up with from this problem? X plus Y equals what? 5? So there would be another equation you could come up with. Then you would have 2 equations, and you would, well, I don't know, you could do whatever you wanted. You could substitute in, or you could, multiply through and do an elimination. But that would be 2 equations that you could come up with for this system. Okay? You guys need to be able to do that kind of thing. Okay. All right, now we're going to look at some other stuff. Take a look at the packet that I just gave you. And right on the top, and this is kind of a bummer, I ran off the key instead of the actual quiz. But let's look at this and let's talk about what you know, and try to cover up the answers. I know that's hard. Right there on the front page that says name, it says me up there, my key. And we are going to see how much of this we remember how to do from last year. Anybody remember what the definition of a matrix is? What is it? It's a rectangular array of numbers arranged in rows and columns. So when you look at, on the quiz here, I have matrix A. There it is, a rectangular array of numbers arranged in rows and columns. How many rows does this matrix have?
2.
These are rows. Look at my hands. These are rows. 2. These are columns, just like the columns on your house or the White House or something. These are the columns. There are 3. This is called the dimensions of the matrix. It's how big it is. We say this matrix is 2 by 3. So if I said to you, what are the dimensions of matrix B, which happens to be question 4, what are the dimensions of matrix B? You would look at it and say 2 by 3. What are the dimensions of matrix C? 2 by 2. When the dimensions match like that, it's called a square matrix. And in matrix land, squares are special. We like square matrices, and you'll see why as we go through some more problems. Dimensions, rows by columns. These guys, the numbers inside the matrix, are called entries or elements. So when somebody talks about the entries or the elements, they're just talking about the numbers that are inside there. And we can identify those numbers by their position. So for example, if I want to talk about this 3 right here, but I'm talking to somebody who can't see the matrix. Maybe I'm talking on the phone with someone, and I'm talking about this matrix. I could describe that entry right there with a little a, which signifies it's part of matrix A, and the subscript 2, 1. That is not a 21. I don't say 21, I say A sub 2, 1. What do you think that 2, 1 tells me? Row 2, column 1. Anything we do, the first number is the row number and the second number is the column number. So row 2, column 1. How would you describe this 2 right here? What would that 2 be? A sub 1, 3? So when I look at question number 3, it says find A sub 2, 1. A sub 2, 1 is the number 3. Everybody got it? All right, now, there are 2 things happening in question 1. First of all, there's a 2 in front of the matrix B. What do you think we're going to do with that 2? Times everything in B by the 2. Anybody want to take a wild guess what we call the 2?
Coefficient.
That'd be a great word, but not in matrix science. It's called a scalar. That's called a scalar. Where have you heard that word before? When we talked about vectors, remember? Because a matrix is nothing more than a bunch of vectors all stuck together, so the vocabulary actually overlaps. All right, so we're going to start by taking matrix A and adding 2 B's to that. So that would be 1, negative 1, 2, 3, 4, 0, plus 2 B's, which would be 2, 2, 2, and 4, negative 2, 10. Now, how do you think we add these together? Yeah, I already multiplied B by 2. I already did that. Now I'm ready to add them.
You add each one in the row 1 column.
Add corresponding entries. So this is the 1, 1 spot, the row 1, column 1. I'm going to add it to the 1, 1 spot over here. So that would be 3. And then I'll have 1 and 4, 7, 2, 10. What do you think about that? Now, if that's the way we add matrices, and it is, what's the rule for adding matrices? Can I just add any 2 random matrices I find out there? They have to have the same dimensions. If you are going to add, they have to have, or subtract. Addition and subtraction are the same. If you're going to add or subtract, they have to have the same dimensions. You will encounter many impossible problems in matrix land because the rules are so specific. They have to have the same dimensions or they can't be added. Look at question number 2. I wrote in big letters, no can do. Why is question 2 impossible? Because matrix C is a 2 by 2 and matrix B is a 2 by 3, and they will never be able to be added or subtracted unless their dimensions match. Okay? I know you're all tired, but you need to get your heads up. Thank you. All right, now we're down to number 5. What's going on in question number 5, do you think? That's a multiplication. This is not hard, but it's a little bit more involved than addition is. So we have matrix C. Now, in a minute, you're going to have to do this by yourself, so please pay attention. Could these two matrices be added? No. They can be multiplied. Here's the rule for multiplication. What are the dimensions of this guy?
2,
2
2.
by 2. I always write them down. What are the dimensions of this guy?
2, 3.
2 by 3. When these two match, when the number of columns of the first matches the number of rows of the second, you can multiply. So you could have an 8 by 5 and a 5 by 92, and they would be multipliable. You can multiply them together. These have to match. These tell you the size of your answer. So our product is going to be a 2 by 3 matrix. Here, our product would be an 8 by 92.
That's fine.
All right, so everybody got the rule for multiplication? All right, here's how it works. To get this number in this position right here, which notice is in the first row, first column, we're going to multiply the numbers in the first row times the numbers in the first column. So this is the first row, first column spot, first row, first column. Notice there are 2 numbers here and there are 2 numbers here, right? That's why we can multiply. So we take the first one times the first one, the second one times the second one, and we add them up. So we take first times first, second times second, and add them up. Have you ever done that operation before?
Yeah.
When was it?
I'm just saying yes.
It was a vector dot product. That's how you find the dot product of 2 vectors. You take first times first, second times second, and add them up. If that's a foreign thing to you, oh my, because that's on your exam. How do we find the dot product of 2 vectors? First times first, second times second, add them up. Exactly what we do here. So this gives me a 1, this gives me a -3. I add them up, I get -2. Now, how do you think I'm going to get that number? Well, notice, where is it? It's in the first row, but now it's in the second column. So first times first, second times second, add them up. What do I get? -1 and -4. So this number is a -5. We'll do one more together, and then you're on your own to finish it up. I'm gonna come down here for a minute. Where's that? What's that? Second row, first column. First times first, second times second, add them up. So 2 and 21, that's gonna be a 23. Okay, fill in the rest of them. See if you get what I get, or what I got on my answer sheet. Anybody have a question about any of the numbers that you were supposed to get? So if we were to have a little quizzy poo on Friday, which is the next time I see you, and I gave you 2 matrices and said multiply them, you would be able to do it? All right, here's what I need you to do now. Second page of the packet is called Determinant Extra Practice. Do any of you remember how to find, fold the paper so you can't see the answers at the bottom? Just fold it up so I can see the problem. 1, 2, negative 3, 5. Anybody remember how to find that determinant? This is like a vector cross product. We're going to take 1 times 5, and we're going to take negative 3 times 2. Be careful. What do we do with those? This minus, we subtract. It's always a subtraction when you do a determinant. So you multiply these, you get 5. You multiply those and get negative 6, but then you subtract them. So the value of that determinant is 11. Now, right now, we're figuring out how to find determinants. In a minute, we're going to talk about a couple of applications of them, okay? Right now, we're just figuring out how to find them. All right, try number 2. Can you get the determinant value in number 2? What would that be? I got a 0 on that diagonal, and I got a 15 on that diagonal. And notice it's always this way first. So it's that diagonal first, and this one, and then what do I do with those 2 diagonals? Subtract. So the value of that determinant is negative 15. Okay? Now, look at 3. Oh my.
Oh no.
I know.
I'm scared.
3 is a little bit bigger. There are different ways to do number 3. Now that we have calculators that do this for us, there's really no need to go through the long way, so I'll just give you the short way of evaluating this determinant. This is the biggest determinant you're going to have to do by hand. We're going to get our calculators out in a minute and do some, I know, a bigger one or do this one, doesn't matter how big it is on the calculator. You're going to have to be able to do a 3 by 3 by hand. So here we go. We just recopy the first 2 columns of the matrix. This should look familiar, I'm sure you did it last year. We're going to recopy the first 2 columns. Notice if there are negatives, I have to bring those along. I recopied them exactly. Which 2 columns do I recopy? The first 2. Now, remember how when you did this one, we took this diagonal minus this diagonal? We're going to do exactly the same thing, but on a bigger scale. We're going to take this diagonal, which by the way is what? If you multiply all those together, what do you get? Negative 4. We're multiplying, so we get negative 4. Now we're going to take this one, and we get 0. And we're going to take this one, and we get 0. And we are going to total those up. So now we have a total of this diagonal, this direction. The total, what I call the down diagonal. The total diagonal is negative 4. Now you know what we're going to do? We're going to do the same thing, going this way. So what's that diagonal? Remember, you're multiplying. Negative 16. What's this one? 0. And this one. Now you total those up. You want the total of this direction. So that would be negative 13. So now we have this diagonal is negative 4. This diagonal is negative 13. What do we do with those 2 diagonals? Subtract. So it's going to be negative 4 minus negative 13, which gives me 9. Okay? Now, would you try number 4? It is exactly the same scenario, exactly the same situation. See if you can do number 4. Ask your partner. Look at my answers if you have to, but I'd really rather you didn't. Look up here at the board if you forget the order you do things. Remember, we always go this direction first. I said the answer was -7. Are you getting -7? You didn't get -7? Remember, I subtract. Remember, you subtract. Yeah, remember, anytime when you do this, you are multiplying. So if there's a 0 in that row, it's automatically going to be 0.
Yeah.
Right?
Yeah. This one is right. So it should just be a king. Wait, so the other 0 is listed all there. 0 plus 0.
Now pressing, get your head out. You're making me crazy.
Then it'd be -3 minus 4, which would be.
All right, if you turn that paper over, are there any other questions about finding a 3x3 determinant? We're going to do a couple more things by hand, then we're going to mess with our calculator for a second. But if you turn that paper over, you'll see a no calculator matrix quiz that we took at some point. Do you feel like with a little more practice, number 1 is a manageable problem for you? We just practiced that, right? Look at number 4. Look at number 4. What are we being asked to do in number 4?
Over.
No, prop 4A is multiply A times B. Have we talked about that today? Yes, you haven't practiced it yet, but we've talked about it. How do we multiply? Remember, row by column. How about B? Do we feel like we can do B? That's a subtraction problem. We first multiply B, matrix B by 2 and then subtract. Okay. Now C means find the determinant. Here's a piece of information I didn't give you. C is impossible. C on the quiz here is impossible because the matrix is not square. I did tell you that square matrices are the most special. There are things we can do with square matrices that we can't do with others, and one of those is find the determinant. If the matrix isn't square, you can't do a determinant. So when I've asked you to do the determinant of C, you would say impossible. No can do. Not square. Now that leaves us with 2 problems that we're not sure what they mean. Problem 2 and problem 3. Right? So let's talk about problem 2. Did you guys, does Kramer's rule sound at all familiar? Did you guys do Kramer's rule last year? It sounds familiar. Okay. Here's how it works. Notice it's a system of equations. If you were stranded on a desert island and found this problem and nobody was around to give you any directions, you just found this, what could you do with it? Substitute, eliminate. You have methods to solve this. Now I'm going to give you a third option. Some kids love it, some kids hate it. You'll just decide for yourself if you don't remember how it works. Step 1. Find the determinant of the coefficients. So my coefficients are lined up. They have to be lined up. X over X, Y over Y. I'm going to evaluate that determinant. We know how to do that. What is the value of this determinant? 1 minus -6, that would be 7, right? minus negative 6. Now, that 7 is the denominator of x and y. Remember, your job when you have a system is to find x and y. Where do these cross? What is the x value and the y value? For both of them, they're going to be fractions, and the denominator is 7. The numerators will be other determinants. These numbers were your x's, and these numbers were your y's, right? So far, we haven't used these numbers. To find x, take out the x numbers, the 1 and the 2, the x coefficients, and replace them with your constants. So cut this out and paste it right there. So your x determinant would be this. Now, does everybody follow that? When I'm solving for x, I take my x numbers and replace them with my constants. And then guess what I'm going to do for y? I'm going to replace the y's. So I'm cutting these out and gluing them right here. Now I'm going to evaluate that. All right, so what's that numerator determinant? Negative 7 minus negative 21, that'd be 14. So x is 2. 7 minus negative 14, that'll be 21. 3. Now I know what some of you are thinking. You're thinking, who in his right mind would do this when I could substitute or eliminate? Let me show you what it could be an advantage. Notice, I made that up. Just randomly made it up. Do you think I made this one up randomly? No, I rigged it. So that you would get this nice, beautiful answer on a quiz. But this one I just made up. Let's go through Kramer's rule with this one, and I think you'll see an advantage. So step one, find the determinant of the coefficients. Okay, what would that be?
21 minus 8 plus 8, 29.
29? So your denominators for x and y are going to be 29. And now I'm going to take, these are my x's and my y's. I'm going to take my 5 and 2 and put them here. And put them here. Okay, so tell me about x. What's x going to equal? $39 over 29. Isn't that wonderful?
Yes.
All right, what about y? Six minus 20, negative 14, 29. Bye. You need to take that with you. You need to take that with you. Check out at the office, yeah. Now, can anybody see an advantage to using Kramer's rule? I want you to stop and think about using substitution or elimination.
You can always do it.
When you did substitution or elimination here, you would solve for either x or y, right? And then what would you do? Let's say you solve for x and got 39 29s. Then what would you do?
You have to plug that back in.
You have to plug it back in. Which is okay,
just
but
really
it's hideous. Now, notice that using Kramer's rule, did it really even matter to me what the numbers came out to be? No. I just build my fractions and go on.
So if
And
it's like
all
a
of the
random-
arithmetic is
It's
easy.
like a random set, basically. That's when you want to take advantage.
A lot of people do it all the time because you don't have to do that back substitution, then you don't have to plug back in. But it's up to you. On your test, you will be asked to solve using Kramer's rule, so you need to know the procedure. But that's it. Okay? All right, we have one more thing to learn. I know it's a lot, but that's what happens when you have two periods in one. Number 3 says find the inverse. All right, that's what that notation means. It means find the inverse. That means inverse. You will only be asked to find the inverse of a 2 by 2. So this is the only size matrix you have to do by hand. We are, I promise, after we're done here, going to get the calculator out and see how it works. But you need to be able to find the inverse of a 2 by 2 without a calculator. It's real easy. Step 1, find the determinant. What is the determinant of that matrix? Now, we just talked about that, the determinant. What would it be? Negative 34. So your inverse is going to be 1 over negative 34. Now, let's talk about this for a second. Can I find the inverse of just any random matrix? No, because if part of finding the inverse involves finding the determinant, what kind of matrix do I have to have? Square. They have to be square. If they're not square, they have no inverse because they have no determinant. Also, do you suppose it's ever possible for the determinant to be 0? That would be a problem here, wouldn't it? There'd be no inverse. They're called non-invertible. If their determinant is 0, they have no inverse. This one's okay, so here we go. Finding the inverse of a 2 by 2 is a 2-step process. Step 1 is find the determinant. Done. Now watch this. This is just one of those goofy things you just have to know. You'll probably forget it. It's a perfectly normal, happy, healthy life if you forget it. But we got to get through this test, so we're going to learn how to do this. We're going to take these two numbers right here. See where I'm pointing? And I'm going to switch them. So I'm going to put the 4 here and the negative 1 here. I simply take these two numbers and I switch them. If we had time and we're doing bigger inverses by hand, you would see why that is. But since we're only doing 2 by 2s, these are always just going to switch. We don't have to go through all the steps. These are going to switch. These two are going to stay where they are, but their signs are going to be changed. So this is a positive 6, it becomes a negative 6. This is a positive 5, it becomes a negative 5. So these two numbers physically switch places. These two numbers, you leave them where they are, just change their sign. This is a scalar. We're going to distribute it through. So we're going to get negative 4 over 34, 5 over 34, 6 over 34, and 1 over 34. We'll reduce any fractions that may be reducible. So that one reduces, and this one reduces. And that is your inverse. Now it's easy, but there are steps to remember. So let's go back through that process. You've got a matrix. Actually, let's just do a different example.